All right, last time we added a Death Star back to the page. We also changed the motion formulas for the stars to make an impression that the spaceship turns vertically and horizontally. However, when we try to enable a Death Star, it did not go the same direction as other stars. And when we turn, the Death Star turns with us. So now we need to update our motion formulas. So the Death Star moves with the other stars when we turn. Now, in order to do that, we need to apply formulas to move the Death Star, because currently the Death Star is just in the center of the screen, and we never change its X and Y coordinates. Now, the formulas to move the Death Star are, as you can probably tell by looking at them, very similar to the formulas for moving the other stars, except the key difference here is that here for the stars, we multiply by the radius of the star, and for the Death Star, we multiply by 2. And the reason we multiply by 2 is because we're assuming if a Death Star is going to be closer than the other stars, and as a result, it should approach us faster. Now, when the Death Star becomes invisible, in here, we reset its X and Y positions to the center of the screen, as well as its height. Now, let's see how it works. So now, as you can see, when we turn, the Death Star turns with the other stars, or moves with the other stars. However, when we start turning and then turn all the way around and back to the star, we do not come back to it because we did not program a real three-dimensional environment, like in Minecraft, for example. Now, in this case, when we miss the Death Star, it is better to just disable it the same way as we previously disabled when we came too close. So as you can see here, the height isn't increasing that much, and it's just really far off the screen at this point. Now, in order to disable the Death Star, we need to update our condition here to also detect when the Death Star exits the screen from either of the 4 sides. And so we need to update this if with new conditions. So we kept the previous condition that the Death Star's height, if the Death Star's height is greater than 100,000, then we make the Death Star disappear. And we added 4 more conditions with these OR gates. So with these OR operators. So if either of these 5 now conditions is true, then the Death Star will disappear. And so in here, these two conditions check whether the Death Star exited the screen through the right or left side. And the way that we can tell, and so this condition is checking whether the Death Star exited through the left side of the screen. And we can check if the Death Star exited if, let's say we reset ourselves. So the Death Star exits our screen when its right edge exits the screen. And in that case, we want the Death Star to disappear. And so we take the X coordinate of the center of our star and we add half the width. And that gives us the coordinate of the right side or the right boundary of the Death Star. And if the right boundary or the right edge is went past the left edge of the screen, so it's less than 0, then in that case, we want the Death Star to disappear. Similarly, in here, we take the coordinate of the center, the x-coordinate of the center of the Death Star, and we subtract half the width, and that gives us the left side, the coordinate of the left side of the Death Star. And now when the left edge of the Death Star is greater than the width of the canvas, that means the Death Star exited the screen through the right side, and we want to make the Death Star disappear. Now, the similar idea is applied here, except with the top and bottom edges. And so if either of these is true, then we make the Death Star disappear. Now, when we refresh the page, when a Death Star exits the left side of the screen, it disappears. Similarly, if it exits the right side of the screen, it disappears. And same for bottom and top, like so. Now we can play with this page and try to approach the Death Star using our sliders. However, even though it is definitely possible after some practice, it would be much easier if we could operate our spaceship using buttons on our keyboard. Fortunately, it is possible to configure keyboard button event handlers on a web page. And in order to do that, we need to add a new event handler to the body. And this event handler will handle the key down event. So on key down is our event handler, and it's just the key control function with event passed in as the input parameter. And this event object will just contain information about the key that was pressed, which will tell us in which direction we have to move the spaceship. Now, we need to actually add the event handler now. So in here, we'll add a new function called key control with this input parameter. And so first, this line is just a fancy way of writing if this input parameter is undefined, then we just set it to this input parameter. And this input parameter, sorry, not input parameter, and we set it to this value. And this is just the event that was triggered. So if we don't have an event passed in, then we just take the event from the window DOM object. Now in here, we have a switch statement, and we switch through the key code from our key down event. And so this key code is just a unique code for the key that was pressed. So each key has a unique key code. And in our case, we want to key code 37 is the left arrow. So if the key code is 37, we turn left. If the key code is 38, that's the up arrow, and we want to turn up. If the key code is 39, it's the right arrow, so we turn right. And if the key code is 40, then it's the down arrow, and we turn down. And now we have a default case, but it's empty, and that is because if we press any other key than our 4 arrow keys, we don't want the program to actually do anything with our spaceship. Now, when we refresh our page, we can now move the spaceship up and down using our up and down arrow keys, and you can actually see the sliders move in here. And we can also move right or left like so. Now, keep in mind that if you're going to adjust some other slider beforehand, and then you're going to use the arrow keys. Doesn't matter left or right or up or down. He will actually move that slider as well. And that is just because that's how the default slider controls are configured in the browser. And we can't really do anything for that, except for before moving the spaceship with arrow keys, just click outside of the sliders. And in that case, you'll deselect the sliders and you won't move a slider that you don't want to move at a particular moment. Now, also note that as you approach the Death Star and it gets bigger, and it actually gets bigger than the screen, and we get scroll bars, then the arrow keys operate the scroll bars as well. And this is another effect that we can't get rid of, just because of the way that scroll bars are programmed by default in browsers. Now, one of the last things that we'll do with this project is add a hyperdrive. If you remember from Star Wars, hyperdrive makes a spaceship move very fast. And when it moves really fast, the stars become visible as lines that come from the middle of the screen. So first, we need to add another slider. That'll be our hyperdrive control. And we'll need to add the slider in our HTML code. So in here, let's just put it under the refresh interval. And here we just have a new range input for our hyperdrive that goes from 0 to 100. And now in JavaScript, we need to add a new variable, which will represent our hyperdrive control, like so. And now let's make hyperspace lines when the hyperdrive value gets greater than 0. So currently, we have this logic for drawing stars, and we just draw them as circles and we fill them. However, and even though this worked fine for normal flight mode, for hyperdrive, we actually need to draw lines instead of circles. So let's just put all of this logic into an if, like so. So if the hyperdrive value is 0, that means we have no hyperdrive on, and we will just use a regular logic. However, in this else block, this is for when hyperdrive is on. And now we'll need to use a different logic for rendering our stars. So the key difference here is that here we're drawing the stars as lines instead of circles like we did previously. And lines, they require a starting coordinate and an ending coordinate of the line. So here we begin the path of our CTX, our graphics context paintbrush, and here we calculate the new coordinates of our line, the ending coordinates of our line, and I'll get back to that in a second. So in here, we move our virtual graphics paintbrush, and we put it at the star's X and Y coordinate. And then, using this line2 function, starting from this coordinate, we draw a line to our new X and Y coordinates to draw the trail of the star. And here we set the width of the line to for radius times 2, so that the star is the same width as it was in here in this logic. And here we actually use the stroke function to draw the line instead of fill. Now the new coordinates for the stars. So first, we make them relative to the previous coordinate of the star. And now here, to that coordinate, we add this value. And so in here, this factor is just the star's position relative to the center of the screen. And so pretty much what that gives us is if it starts to the left of the screen or to the right of the screen, this will be either negative or positive, and this affects the direction of our trail and allows it to be towards the center of the screen. And also what this gives us is that the further away a star is from the center of the screen, the longer the line is. Now in here, we also make the length of the trail relative to the value of hyperdrive. So the idea here is that at higher values of hyperdrive, the stars become more and more like lines instead of circles. Here we also make it relative to the star's radius. So if the star is further away, then we should see less of a trail because it's going to be moving on our screen, is going to be moving slower relative to us. And here, this formula just makes the length of the trail relative to the age of a star. And actually, that's a similar logic to what we used in here for calculating the radius of the star. And now in here, we actually draw the line. Now, when we refresh the screen, when hyperdrive is off, everything looks normal, but when we turn hyperdrive on, and actually, let's move a bit faster, you'll see that hyperdrive lines leave off these trails behind them. And that is because the lines are not wiped out properly. In our existing logic for wiping out lines, over in here, we just draw black circles on them. And when we put black circles over the previous stars, it makes them invisible because the background is black as well. Now let's temporarily make these circles red just to see how the logic works. Now, when we refresh the screen, here I'll actually slow the speed down and refresh it. You'll see that after the star is drawn, the red circles erase the previous positions of the stars. Now if I refresh it again and turn hyperdrive on, the circles no longer wipe out the stars properly because the stars are now lines, and we have these trails left over. And wiping these stars in hyperdrive mode becomes too complicated. And so we'll just do it by calling a refresh screen function that we created previously and wipe the entire screen at once. So in here, first, let's change this back to black. And here we're going to put this in an if. So we only use this logic if hyperdrive is off. Like so. And now before our for loop in here, we're going to add another if. So if hyperdrive is greater than 0, so if we have hyperdrive on, then before each for loop, we'll call our refresh canvas to wipe all the previous stars. And now when we refresh the screen, our hyperdrive is a lot more smooth and it does not leave the trails that it did. Now let's try to turn while hyperdrive is enabled. And we can turn, but it does not look very realistic. In addition, it might not be safe to turn the spaceship on such high speeds. So let's try to disable turning when the hyperdrive is on. So in here in our code, we will put brackets around our if first, and then in here, we're also going to add this line of code. And in here, we set the value of our horizontal turn and the vertical turn input to 0. Now, the way this works is JavaScript assigns values to variables from right to left. So first, it takes 0 and assigns it to the vertical turn input value. And now it assigns this new value of the vertical turn input, which is 0, to the horizontal turn input. So now both of these become 0 in one line. And now another interesting thing here is that we can not only read the values from the sliders, but we can also set the values of the sliders as well. And not only sliders, all inputs as well. And so we can pretty much set the slider to where we want it to be. Now, if we refresh the page with hyperdrive off, we are free to turn in any direction we want. But now, if we turn hyperdrive on, you'll notice that the two sliders snap back into the center. And now, if we try to move them, if we try to move these sliders, they'll go back to the 0 position. Now, if you want to take the risk of unsafe operation of the spaceship, you can disable the restriction to do turns during hyperdrive flight. And the way you can do it easily is just by commenting this line. Now, comments in JavaScript are put with 2 slashes, or indicated with 2 slashes. And they pretty much indicate a line of code which JavaScript will just ignore. And they are used to write pretty much explanations on how your code works. So for example, here, after this line, we put 2 slashes. So everything after these 2 slashes is not checked by JavaScript. And here we can just write an explanation of this, what this line of code does. Similarly, if we put 2 slashes in front of a line of code, which we want to disable, JavaScript will treat this as a comment and not run this line. And now if we refresh the page, now we are free to turn into any direction that we want during hyperdrive flight. Now, another thing here is that when we fly forward really fast with a lot of hyperdrive, the greater the speed, the more stars should appear ahead of us in the middle of the screen. But currently, we have too many stars that appear on the sides of the screen. And we kind of have like a hole in the middle. Let's try to change the logic of positioning new stars and make it dependent on the hyperdrive value. So our previous logic here is that we just put our new star in a random position on the screen. And now we'll update these formulas with new ones. Now in here, this new formula, first, we make the position of the star relative to the center of the screen. And now in here, we add this value, which is pretty much just its offset from the middle of the screen. In here, this factor is this is just a random number from 0 to 1. And when we subtract 0.5, this whole thing becomes a random number from negative 0.5 to positive 0.5. And what this gives us is, by having this number go both in the positive and negatives, we can make stars appear on either side of the middle of the screen. And now we multiply this by the width of the screen. And since this ranges from negative 0.5 to positive 0.5, if this is positive 0.5, then this is half of the width. And when we add half the width to half the width, we get the full width of the screen. So ranges from the right side of the screen to, if this is negative 0.5, then we subtract half the width from half the width, and we get 0. And so it ranges to the left side of the screen. So alone, this and this will give us a random point anywhere on the screen. But here we also add this factor. And in here, this is 1 minus the value of hyperdrive over 200. And what this does is it limits the new position of the star depending on the hyperdrive value. So when hyperdrive is 0, this is just 1. And so the stars can appear anywhere on the screen. However, when we increase hyperdrive to 100, let's say, then this value will be 0.5. And that means that the stars can only appear in a small section of the screen in the middle. And now we'll apply a similar logic for the y value of the stars, like so. Now, when we refresh the page, this is more obvious on slower speeds. You'll notice that the stars mainly appear near the center of the screen. Like so. Like so. And so if we have no hyperdrive, the stars appear randomly on the screen, but as soon as we add hyperdrive, you'll notice that they appear closer to the center of the screen, which is what we wanted. Are there any questions so far? Yes, Alice?
If you want to go backwards, can you put negative numbers?
Yeah, we can put negative numbers for speed. So currently, if we inspect our speed slider, you can see that its minimum value is 0. So when we have it in its minimum position, we are just stopped. However, we can put negative values in here. So let's just temporarily put minus 200. And now we can move backwards. However, we didn't implement any sort of logic that makes the stars from disappear from middle and reappear on the edges. So this just creates the effect that we're zooming out of the galaxy. And now this is just a galaxy far, far away. And it becomes sort of like a small dot, concentrates into one star. Now, we can turn the speed back up and actually zoom in into this. And as we get closer and closer, you'll see the stars begin to reappear. And now we enter this. And we go back to normal flying mode. Now, also, if we fly backwards and turn on hyperdrive, then we get this sort of effect. And if we go back, the lines will reverse direction and we go back in the middle. And now this just turns into regular hyperdrive mode after this. However, here's another interesting side effect. So here, let's inspect our speed slider again and make us move away a bit faster. Let's just say 10 times faster. Now, let's increase this 10 times as well. Now, when we start going back, keep in mind the stars are now really, really, really far away from us. And as we approach them, actually we can speed this up even more. Like so. You'll see the stars form kind of like an X on the screen. And the reason for that is when we get really, really far away, JavaScript starts rounding the numbers with a lot of decimal places. And so when it rounds them kind of weirdly, then the stars kind of stick to an X shape for a cool visual effect. Are there any other questions? All right. Thank you for watching, and I'll see you next time.